This video file was recorded in Sabunja University during recitations for the CS204 Advanced Programming course as it was given in the spring semester of 2017.
Good afternoon, everyone. Let's start with the third week of the Advanced Programming course. You remember the pointers last week, and we are going to do a brief review about the pointers, and we will start with a new topic during the second class. It's about linked lists. But first, let's go through pointers, and let me refresh your memory about pointers, since our first example will be exactly about that. So, you'll see exactly why we need pointers. All of the job can be done with references, as it is the case in some programming languages that don't have pointers at all. They have only references, and one of them is Java. But in C++, we have both of them. So what were the pointers doing and why we needed them? Very briefly, this is something that we already saw during the last week. I'm declaring an integer a, which is equal to 5. Here, I'm declaring a variable, which is called ptr, and it's a pointer. How do I know that it's a pointer? I have this star here. Okay? So, I have this a, and the value of a is 5, and I have a pointer. This guy is pointing somewhere, but for the time being, it's not initialized. It's not pointing anywhere, you can assume. Actually, there are some numbers here, and it's pointing to a memory location which makes no sense. Okay? Or you can assume that it's not initialized. If I want to initialize it, this is how I use it. ptr is equal to, if I want, let's say the address of this guy is 100, ampersand a, when ptr is pointing here. If I want to change the value, then I'm using star ptr. But pay attention. This is for the initialization part, and this is for accessing the value to which a is pointing. So ptr is pointing. So ptr is pointing to 100. When I say only ptr, it's 100. But when I say star ptr, it's the value of the content of the address 100. So if I want to change that value, and if I say this is equal to 6, then this guy is going to be 6. Another syntax that you should know is this one. ptr2 is equal to new integer. We already saw it last week, but I think we should explain it again. What do we do with this stuff here? Let's go with this part. When I say integer, I'm declaring a new integer. New, when I say new, basically this is what happens. I have an integer. This poor integer has no name, but it has an address. Let's say the address of this guy is 104. I cannot say it's 101, 2, and 3, because this guy has consecutive 3 blocks of addresses, okay? It's 4 bytes. You remember it from last week. Intentionally, I'm making it 104, although it can be anything else, except for 101, 102, and 103. Since those are reserved for this a here, since a takes 4 bytes, 32 bits, okay? So, when I say integer, the compiler reserves a block of memory. When I say new, it's reserved, and it returns the address of that guy. And this address is, in this case, 104, and it is assigned to the ptr2. So I have another ptr2. We have here 104, and this ptr2 is pointing here. Okay? We don't have any value here. We have a value, but that value makes no sense. If I want to change the value of this variable, which has no name, it's a kind of homeless man that you just pick from the street and give him a home to live, and you say, okay, I don't know his name, but I know his address. Okay, this is something like that. And if I want to change the value of 104, of course, we do, as we did previously. PTR2 is equal to 10, let's say. And I have 10 here. Okay? Intentionally, I'm emphasizing this new stuff because we are going to need it for the next couple of weeks or so, maybe till the end of CS204. With this new, you allocate a new memory block. Okay? In this case, it's integer. It might be string, it might be double, it might be whatever, another type that you can declare, a new class maybe. Now, also something else. If I want to delete this guy here, so I've created it, and I want to delete it. When the program exits, everything is deleted from memory. Or if I call the function, everything that is associated with the function is deleted. Okay? But sometimes I want to delete it during the runtime. I'm not exiting the program, I'm not finished with the function, but I want to delete it. This is how you do it. When I say delete PTR2, let's say, well, this guy here is deleted. We don't have it anymore. You might say, okay, why? Because you want to free memory. You don't want to waste your space. Now, if we want to go more crazy, I'm not going to cover pointers of pointers. We did it last week. Eventually, probably in CS204, we're going to deal with pointers of pointers. But let's see how array of pointers work. So, can you give me a clue? How can I declare an array, a built-in array, of, let's say, 10 pointers, integer pointers? What should the syntax be? How it should look like? An idea. So if I declare an array of integers, all integers, let's call it int array, and I want to have here, let's say, 10 elements, and we are talking about built-in arrays, not dynamic ones. This is how I'm doing it. But if I want to declare an array of pointers, of integer pointers, what should be the syntax? What do you think? Star here. Yeah. Before the integer.
No, for integer.
Here. Why do you think? Have you seen it or you're making it up? Okay, it's correct. It might be intuitive, and it is intuitive in start, in a way. So, PTR int array. I'm making up the names now. It's 10. We're going to see an example now where we will have an integer array. And here we will have some numbers, index 0, 1, 2, and so on. And we will have an array of integer pointers, and we will somehow arrange that the index 0 of the integer pointer array is going to point here. Index 1 is going to point to the index 0 of the integer array. Index 1 of the integer pointer array is going to point to the first index, so index 1 of the integer array, and so on. And let's see how it's done. If you understood this part here, it's straightforward. So can you tell me, if I know, let's say the address of this guy is 200, what's going to be the address of the first index number 1 of the second element? 204. We have 208, and so on. So basically you can increment it by 1. Okay? This is pointer incrementation by 1. Okay? It might be 4 in integer, but in pointer arithmetic it's 1. If the name of this array is integer array, so this is the name of this array, integer array, and if the name of this array is pointer integer array, can you tell me how can I set, let's say, the first index, the one with the index 0, the first element of the integer pointer array, to point to the index 0 of integer array? Can you tell me? So how can I access the first element of this array, the 0th index?
Array 0?
Yes. So int array 0. I'm accessing this one. It might be, let's say, 7. Then we have 9. Let's make those with odd numbers. Not 7, 9, 11. How can I access the address of 7?
Star.
Ampersand. Very nice. Now I want to assign this address to this guy here. So how am I going to do that? Yeah, but this is when I declare it. See, it's star pointer. But when I use it, like that, but here, it's ptr integer array, ptr integer array, and yes, we don't have to put star anymore. Yeah, you see, we don't have star here. ptr is equal to ampersand a, and here is the same. The 0th index. Okay, so this is it. We're going to see an example that is doing this stuff. Okay. So download your codes if you haven't done that. Start a new project. Let's run the code first and let's go through the lines. I'm not going to get engaged in details like changing the project name, blah, blah, blah. Let's start immediately. Open folder in File Explorer. We have here the solution folder. Let's go with week 3, namely with array of integers. Just copy paste this piece of code and send it to the solution array. Then add it at existing item, the newly copied one. Add it to your solution. Let me change the size of the font. Okay, I'm going to run it now. I'm going to see the output, and I'm going to explain the code line by line. So let's see the output first. The program initially prompts us to give an input of 6 numbers, and I'm going to give, let's say, 6 odd numbers: 7, 9, 11, 13, 15, 17. I'm printing the array. I'm finding the sum of the array, but pay attention, through the array of integer pointers. Okay? So I'm finding the sum of 7, 9, 11, blah, 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 till 17, I think. Yes. We have 6 elements here, so this is index 5. This is 17. And I'm finding the sum using those pointers first, and I find that it's 72. And then I find the same sum through the array of integers directly by accessing those numbers, as we have done in CS201. And we see that that number is the same. Of course, it is the same, since those pointers point to corresponding memory locations of the integer array. This is the intro part. So we have 2 variables here, and let's see how they work. First, let's go with the functions. We have a function called printList. Basically, this function is printing which one? The array with the integer pointers. Okay. So as a parameter, you see I'm taking an array. Like you can see that it's an array from this guy of integer pointers, the first parameter. And since we are dealing with dynamic array, with built-in arrays, I have to send the size also, because we don't have the property .size here, the member function size. That's why I have to explicitly send it as a parameter. Then I'm printing this stuff here, printing the array, blah, 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 using the pointer array. I start from 0 to size. And in order to access the value to which pointers are pointing, of course, this is just to assign the address. But in order to access, if I know here I have 200, okay? If the address of 7 is 200, I have here 200. Here I have 204, 208, and so on. So this is the first index, and the second index, index number 1, and so on. In order to access the value to which this pointer is pointing, of course, I'm using this syntax here. I'm using star, you see here? If I want to change the value to which the PTR is pointing, to access, change it or take it, read it, I just say star PTR, meaning that 100 is PTR. So it's pointing here. Star PTR at 6. Okay? Same applies here. The same logic applies here. In order to access element number 7, this guy, number 7, integer 7, I'm going to do it in this way. I'm going to write it here. So star PTR integer array, let's say 0, or let's generalize it to I. Okay, so PTR integer array I is 200. Star of that is the value to which it's pointing is it's 7. So I start from 0 to size, and I print all the values to which the pointers of the array are pointing. Okay, not the value of the pointers. I'm not printing 200, but I'm printing the value to which the pointer is pointing. And it's done with this star here. So this is the print list function. We are going to use it in main. Now let's go to main. What do we have here? We declare a size, a variable integer, an integer variable which is constant. Its value is 6. We are going to have 6 elements. Then I'm declaring here, you see, a pointer array of integers. Okay, an array of integer pointers. I'm declaring a built-in array of integer numbers only. And I start counting the numbers. I prompt the user to enter 6 numbers, and I'm reading the numbers one by one. And you see I put those numbers in the list of integers, okay? The other one is list of integer pointers. This one is list of integers. So when I enter 7, I put them here one by one with this for loop. It's iterated 6 times. Now, I'm trying to get the addresses of these guys here, of the integers at the integer array, with this for loop. And we are doing the stuff using the syntax that we already saw here. So from 0 to size, each index is the corresponding address of the integer array, okay? Then I print the list, and here I send list of integer pointers. This guy here, it has the pointers towards the integer, and I print it. I send the size also. I call the function print list. Afterwards, I declare a variable, which is called sum array. I start from 0, since this is sum. And here I find the sum of elements of the integer array. Sum plus equal list of integers. So this is the list of integers. Should I change the name of this array list of integers? I don't think it's necessary. Okay. I print that sum. And I think it was 72 in our case, if I'm not mistaken. Then I define another variable, sum pointer. This is that one. I start from 0, since this is sum. And here you see I'm adding the values one by one of all of the pointers of the integer pointer array. Okay? That's why I use star here. I'm using this stuff here. And of course, the sum will be the same, since basically I'm twice adding the same numbers from the same memory location. And I'm printing the sum of elements in the array through the array of integers is blah, blah, blah. through the array of integer pointers is I think we should have here pointers, and here we should have only integer array, because with some array here we are not using pointers, but with some pointer we are using pointers. So some pointers we use here pointers. Okay, this is it. Let me run it again. I'm asked to give 6 numbers. This is it, 72 again. Any question? This was straightforward, I think. Just to warm you up about the upcoming examples. Okay, now let's go with the second example called dynamicArray. Just copy paste the content of this guy. We have here an input file also. And before executing the code, just let me ask you, or let me explain you some stuff. We are not going to need this guy here. I'm erasing it. Now, integers have 4 bytes, 32 bits. Short integers have 2 bytes. Booleans have 1 byte. Can you tell me about string? About type string? How many bytes does a variable of type string have? Think about the answer. How much? 8. Who was that guy? Okay, what if you say 8 bytes. What if I put in one string all the available books in the world? Can I do that? Why? Can I put one book of 600 pages? No, it has 8 bits, 1 byte, the character. No, I'm asking about strings. How many bytes or bits does a string have? Yes?
A string, can I think a string is array of characters?
Array of characters, but it's a new type. So it is array of characters, actually.
Depends on the character inside the string.
But is it fixed? I mean, for the character, can you say it depends? It can be 8, it can be 10 bits, it can be 12? Or it's strict? It's fixed? It's fixed. You cannot have character of 10 bits. It's always 8 bits or 1 byte. 8 bits make 1 byte. Integers always have 4 bytes or 32 bits. What about the string type? You think 4 bytes? Always? What if I copy paste, if I put the whole book of 600 pages in one string? Is it 4 bytes? So, what do you think? It's dynamic. Unfortunately for us, it's dynamic, or fortunately maybe. And we have been lying to you. Basically, when you have said something like, I'm defining a string name, by default, although you are not using a pointer here, this is a kind of a pointer. And it's pointing to the first, so name, and let's say this name is equal to rtrim. So somewhere in memory, you have this guy, rtrim, and this is divided like this. In the end, you have a special character, /0. This name points to A only. Okay? So, and when I'm printing name, it basically is incrementing the character 1 by 1, cout, and printing all the characters. But since the string variable is dynamic, we should know where we are ending, okay? That's why we put this special character here. Just like you remember input files or text files. So we have a text here, let's say CS204. And in the end of each line, we have this character, new line. We don't see it, but it's there. Okay, so we have here several lines. And in the end, what do we have? End of file character. This is the special character, end of file. Okay? We don't see it, but it's there. Well, strings have this character. We are going to deal with this special character in a couple of weeks or so. Okay? But basically, you didn't know that because you didn't know what a pointer is, but you now what a pointer is. And when you declare something like this, actually it's a pointer that is pointing to the first character. Okay? And then we increment and go to the other characters. We are going to see an example in a while with string arrays. Okay, this is only one string. But what if you want to have something like this? An array we have here string PTRs. Okay, index 0, index 1, index 2, and so on. And this guy here points to, let's say, CS204. This guy here points to another string, let's say, hi there. This guy points to another string, let's say, bye. How are we going to define a vector of strings? But pay attention. You remember this guy here, new integer? We want, when we are going to declare this vector, that's one, let's say of size 10, of strings, we want those guys to exist. Because if I'm declaring it, I just have pointers that are pointing nowhere. But I want pointers to point to something that exists. Okay, maybe those strings don't have a name, okay, but we can access them. And the syntax to do this stuff is the following. I'm going to use the name that is used in the example, string star. Basically, this is a pointer to a pointer. Okay. My list is equal to, you remember the new integer, only one integer was created. When I say new, string, only one string is created. But if I put brackets, and I put count or size or whatever, then this guy is created. So the name of this guy here is not, it's my list. And here we have counter elements. Okay, so far so good. How can I access the 0th string? There are 3 ways to do this stuff. 1, my list, 0. Very simple. 2, we have already the addresses and it's pointing here. So star, very nice. Star my list. Now, if you remember, every string has had its own member functions. Can you tell me some of the member functions of the string class? Which one? Substring, very nice. Substr. Then what? Length, remember length? Yes. Length, add, and so on. So this guy also has the same, every string has the same member functions and properties. Okay. Now, if I want to access, this is for the 0th index, okay? Star my list of 0. So far, so good. But what if I'm dealing with an index I? What should I do? Instead of 0, I'm putting I here. And I put I here also. Let me write it in a better way. Usually I'm telling it right now. This is a kind of a tricky question that the professor usually likes to ask. So pay attention. Now I'm accessing those elements here. What if I want to access the length? What should I do? If I have a string name, if I want to access the length of this guy, what do I do? You remember? Come on, tell me. Name dot length, okay? Now the string is my list I. So in order to access its length, what should I do? Dot length again. What about here? Star my list, okay. My list I, let's say it's index 10, I'm pointing here. It's the pointer. It's a value, let's say this is 1000. This is 1000. When I say my list I can be 0, 1, whatever. I'm telling it's only 1000. When I say star 1000, it's this box here. If I want to access the length, dot length. There's another way of accessing the length, and it's this one. For me, maybe it's the preferred one. My list plus I star arrow length. They do the same thing. Although you can use this guy here, I would suggest not to do like this. My list I can be used in this manner. My list plus I, then you have a star here, and after the star you are accessing the length. So those three guys do the same thing. When we have an array of strings, of pointers to strings, and we want to access the length of each of the strings, you can do it in this way. So my list I, length, my list plus I star, maybe star should be put here for the brackets. Okay. Basically, my list always actually points to the first element here. It's 1000. Let's say it's, let me make another number. It's 10,000. So this is the value of this box. Okay. If I want to access the ith element, I'm doing a pointer arithmetic. My list plus I, it can be 0, 1, 2. If I is 0, then I'm accessing this one. If I is 2, then I'm accessing this one, okay? Star, if this guy is, let's say, 1010, 1100, and when I say start 1100, is this guy here. Point length is the length of this one, okay? Those three syntaxes do the same thing, and we are going to see it in this example. Is this clear? It might be a bit confusing, but not too much. You don't have to take photos. You will have the codes, and you will remember what I'm talking about. So is this clear? Should I go through this guy again? Yes or no? Maybe it will be better when you see the code. Copy paste the dynamic array stuff. Edit. If you want to see the content of the dynamic array input file, it's this one. So basically we will have, how many lines do we have? 1, 2, 3, 4, 5, 6. 6 lines. And when we have a string array of pointers, an array of string pointers of 6 elements. We will have basically 6 pointers. Each line is one of the places to which the arrays are pointing. So let me run the code. We are going to see the output. And what is this guy doing is the following. You see the content of this input file. We have here 5 characters, 2 characters, 1 character, 4 characters in this line. We are trying to find the average of characters of each line. So how do we do that? We find for each of the lines the length of the string, okay, of the characters, and we divide it with the number of lines, and we find the average number of characters. The length of the string is the number of characters it contains. Now let's go line by line and let's see how we do that. We start from here. Of course, I define an if string because nothing else, not f string, because I'm going to read the input. The file name is dynamicArray content. We don't want to ask the user to give the input file name. When you want to open it, you have to use this copy string. It's copy string. We have the line, an integer where we count the line. First we open the file here, and with this while loop we get the lines one by one, and we find the number of lines. Why do we need that? We need that for the dynamic array, because when you are going to create a new array, as I told you there, we will need the number of lines here. Okay, so I'm declaring an array of string pointers, and I allocate memories. In our case it's 6. Okay, new string 6, and this returns the first element of those newly created places for string. Okay, so I create 6 new strings. This one, this one, this one. They're empty initially. Okay, we don't have those by, hi, CS204. With this new, we allocate memory for strings. The compiler is doing that stuff. And I'm returning the address of the first one, of this one. Okay, it's 1000. So my list points to the first address. If I want to go to the next one, I can say my list plus 1. If I want to go to the second string, my list plus 2. This is pointer arithmetic. Now let's see what I'm doing. I'm clearing the flags because a mistake happened. When I try to get the line and I don't have 1, a mistake might have happened. And I start from 0. You remember SIGG? I start from 0, from the beginning of the file. Okay? And again, I take the lines one by one. You see what I'm doing? My list index is equal to line. So I take the first line and I put it to index 0. Increment the index, it's 1. I take the second line and I put it to index 2. Basically, let me show you what I'm doing. If this is my input file, dynamic content array, or what was the name of the file? Never mind. I had here CS, this was the content, CS204 is blah blah blah, okay? So I created this array. Those guys are initially empty, I don't have anything here. My list points to the first element, so it's 10,000. I start with index 0. I start with this SIGG and clear. I make the pointer to point to the beginning of the file. And I take the lines one by one again. As I take a line, I put it to initial index 0. So this guy here is going to be CS204. I increment the index. I make it 1, get another line. Is The content of this guy is going to be is now. Increment the index is going to be 2. Take another line, and so on. I fill this box here. And finally, I'm trying to find the average. First, I find the total number of characters. Initially it's 0, of course, and this is how I do it. Total number of characters plus equal to my list plus I. You see this guy here? My list plus I, point length. Okay, I iterate from 0 till the count of lines. I have 6 lines in our case, meaning I iterate from this index till the end. In our case it's 6, so this is index 5. I go here, my list points here. Plus I, if I say plus my list plus 1, it points here. My list plus 1, it points to the second index, okay? But initially, I start from 0, so I is 0. Total number of characters is 0. Okay, so I have the variable total here. Total number of characters is 0. My list is this one. And I'm saying my list plus I plus 0, it's again this one. The star makes me to access this box. Length is the length of this guy. How much is that? It's 5. So total length of characters is going to be 5. Okay? Now I increment I by 1. It's 1 now. And I'm going my list plus 1. So my list is 1000. Plus 1, it goes to this pointer here. And this pointer points here. With this star here, I'm accessing this box. And I have here the string is. What's the value of length here? It's 2, okay? That's why I add those 2 here. From 5, total number of characters becomes 7. And I do this until the end, okay? My list is going to, now I is incremented and it's 2. Then I'm accessing my list plus 2. My list is always points here, plus 2. It's 1, 2, it's this pointer. Star, I'm taking the length. The same thing can be done with this stuff here. My list plus I, arrow length. Okay? If you ask which one is preferred for you, maybe now you will say, okay, this one is better for us. But I will say use this one. You will see why when we are going to go over the linked lists. Okay? This one is better. But remember, in order to use an arrow, this is a pointer. So this star and this point are substituted by an arrow. There's another way of doing things, as I told you. My list I, point length. Afterwards, we have the total number of characters, and we want to find the average, and the average is total number of characters divided by count of lines, of course. We print it, and this is another important part. Delete my list. You remember the delete PTR here? It deletes only one element, okay? But since here we declared you see, not new string, we declared new array of string. If we want to delete all of these guys that have no name, we don't know their names, but we know their addresses, we have to use this syntax here. Delete the array my list. Okay, it's not going to be deleted only my list, only the first element, only this guy. All of the pointers to which those points are going to be deleted. So this will be deleted, this will be deleted, this will be deleted. The memory will be freed, so another program or another user can use this memory. Is this clear? Okay. With delete PTR, we delete only one element. With delete brackets my list, we delete an array to which those pointers are pointing. Okay. Question?
We delete the pointer.
Not the pointers. We delete those guys. The pointers stay, but we delete this one. We don't have those anymore. Okay? Let me run the program again and you'll have the break. So pay attention. Now I'm using star and dot. When I run it, it's 4.67. Let me comment this guy and uncomment this one. Now I'm using the arrow syntax. It's again 4.76 because they're doing the same thing. Now let me use another one, which is not shown here, but it still works. It's my list I point length. I'm running the code. Why it's not working? Is this the issue? Oh yeah, this yeah. Total number of characters. You're right. I'm not adding them. Yeah. I didn't sleep for the last night, for the whole night. That's why I'm having some trouble. Okay, so it should work now. Yeah. Sorry. Yeah, it's working. Okay. You might be used with this one here. This one might look better for you if you are forced to use star and dots, but try to get used with this one here. And you will see why during the next recitations. So we will be back in 5 minutes.